full carbide tools start to cost a lot more. And this is where a system like this obviously pays dividends, because you're talking about a small amount of carbide. And so you've got that sustainability element. You know, we're not talking about throwing away big lumps of carbide. And obviously it's a reduction of cost, but without a reduction of stability.
Welcome to another Technical Corner. Today we're talking milling with Mitsubishi Materials. I'm here with Robin Peachey. And Robin, milling is huge. It's every kind of material, lots of different kinds of features, all require a milling operation. And you've brought in a range of products to talk about. Let's talk about milling with Mitsubishi Materials. What have you brought in to show us today?
Yeah, well, with Mitsubishi, I think solid milling is a product that we're really well known for. We've been supplying quality tools for a long time now, and I think we're well established in the industry as being a good supplier of these type of products. We've rationalised our programme after the last few years, and now we have, in our general range, we have what we call the MP, which comes obviously with sharp corner, corner radius, ball nose, all the things that you would expect.
Lots of different options. That's this one here.
Yeah. Lots of different versions. We then move into the VQ, which is for stainless steel and what we call difficult to cut materials, so heat resistant alloys in that area. And then finally we move into the VFR, which is for our hard part milling. So we're looking at up to 70 Rockwell C.
Yeah, some serious. And that's a high feed cutter there. That's got a lot of flips on it.
Yeah, that's the high feed version. That's our duplex high feed.
Yeah, absolutely. So you've kind of got a lot of general mills that are really good for a wide range of tasks. Yeah. I see you've missed out two in the middle here. Are these kind of the specialists you want to talk about today?
Yeah, these are the ones that we want to talk about today. We want to talk about our IMX program, which is our replaceable head system. What we've got and what's special about our particular system is that we've got carbide to carbide contact. So our shank is carbide. It comes in various different lengths. You can also have taper form on it. And the head, obviously we've got various different ranges: 3-flute, 4-flute, ripper form, corner radius, sharp corner, ball nose, duplex high feed. You know, we've got everything.
So all of the Mitsubishi milling technology can be found in an IMX style head?
In an IMX style head, yeah. It goes from 10 millimeters up to 25 millimeters. And normally what you find is, as you go into the bigger sizes, full carbide tools start to cost a lot more. And this is where a system like this obviously pays dividends, because you're talking about a small amount of carbide. And so you've got that sustainability element. You know, we're not talking about throwing away big lumps of carbide. And obviously it's a reduction of cost, but without a reduction of stability. You know, because what we've got here is that carbide to carbide connection. We've got a face and taper contact. So the head has got the face, then the taper. And so the carbide of the head marries up with the carbide of the body, keeping a nice stable system.
The kind of last but not least, this product here.
Yeah, this is our VQ chip splitter.
And you can see it on the back here now as well.
This comes from 6 millimeters up to 20 millimeters in diameter, and it comes in a 3 times D and a 4 times D. And what you find is, once you go beyond 2 times D, we're talking about a very low AE and a long AP cut, that you find that you'll start having very long swarf, and you have a problem with recutting. You also have a problem getting, if you're using coolant, getting coolant into the right areas.
Yeah, and you can see the chips being cut up here. So they would normally be this length, but instead with the chip splitter, with the little kind of the staggered radii in them, you've got tiny little chips coming out here.
Yeah, that's right.
Much easier to evacuate.
Yeah. So the chip splitting is staggered, as you say. So we can actually get quite a good wall quality as well, even though it's classed as a roughing tool. We've actually got quite a nice curved waveform. Yeah, so what you'll find in a lot of competitor product is quite an abrupt chip splitter, and the problem with that is you can get fractures on the edges quite quickly and quite easily. And so what we've done is we've adopted this waveform, which obviously gives very good chip control, but also makes the edge nice and strong.
Yeah, absolutely. In terms of cutting data, we can see in the video that actually it's helically milling straight down in this material and also ripping out really, really quickly. Looks like quite fast parameters.
Yeah, this is actually tool steel, and we're running at just over 400 meters a minute. Wow. We're ramping down at 5 degrees. We're going at 0.18 per tooth. And then once we reach the bottom, we ramp up to 0.23 per tooth.
Yeah, that's amazing. Absolutely amazing parameters for tool steel as well.
Yeah, absolutely. Yeah. And it's because we've got this very low AE and high AP with the chip split that we can maintain those high feeds, which is great for things like trochoidal milling.
Yeah, absolutely. Okay, so if someone wants to try any of this out, can you prove it to them how well it works in their actual machinery?
You come to us and we will bring our tools to you and we'll prove out what we can do.
Okay, how can they get in touch?
If you contact our office, either by phone or you can look on our website and find our contact details there, and we'll come out and see if we can help.